Good morning, everyone. Today we will be studying matrix multiplication. So, yesterday we discussed what is a matrix. Matrix is a rectangular array of numbers which are enclosed in rectangular brackets. So, here 6, 4, 24, 1, minus 9, 8. It is a matrix. Now, what is its order? Here the number of rows is 2 and number of columns is 3. So, its order is 2 cross 3. So this is a matrix. We also discussed the types of matrix. Now we also discussed addition of the matrices. So our main topic for the day is multiplication of matrix. So multiplication will be of two types. First will be multiplication of a matrix by a constant. This constant can be anything like -1, 0, 2, 100 or any constant. So let's take an example how we multiply a matrix by a constant. So here our matrix is 4, 0, 1, minus 9 and we are multiplying it with a constant 2. So what will happen? This 2 will get multiplied with every element of the matrix to get the resultant matrix. 2 into 4, 8, 2 into 0, 0, 2 into 1, 2, 2 into minus 9, 18. So as you saw, this was very simple. You can easily do it. What is tricky? Multiplication of a matrix by another matrix. This is not that difficult as students think. It mostly depends on your calculation speed and you need to be very careful with the calculations, otherwise your whole answer will be wrong. So we will be here taking a simple example. All of you must have studied dot product, so it is very similar to that. Let's take example 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. This matrix has order 2 cross 3. This matrix has order 3 cross 2. As we already know that when a matrix of order m cross n is multiplied with matrix of order n cross p, the resultant matrix is of the order m cross p. So here the order of the resultant matrix will be 2 cross 2. So there will be 4 elements here. How do we get those 4 elements? That's our objective. So for getting the first element, we will multiply first row with the first column. We will take the dot product. So it will be 1 into 7 plus 2 into 9 plus 3 into 11. So that's 7 plus 18 plus 33. 7 plus 33, 40 plus 18, 58. So that's 58. Now how do we get second element? Multiply first row with the second column. 1 into 8 plus 2 into 10, 8 plus 20 plus 3 into 12, 36. 36, 8, 44, 44, 20, 64. So similarly we can get the element this and this. So how will we get this element? Multiply second row by first column. So it will be 4 into 7 plus 5 into 9 plus 6 into 11. That's 139. You can tell your answers. Now for the last element here, we will multiply again second row by the second column. 4 into 8 plus 5 into 10 plus 6 into 12. That will give answer 154. And you can see the resultant matrix is already of the order 2 cross 2, which we already know. M cross n, n cross p gives m cross p. That's 2 cross 2. Now I don't think there will be any more doubts in this topic. So we will be taking some more examples which are generally based on the observations, common observations. So here we have a row matrix 1, 2, 3. Why it is a row matrix? Because it has only row. We define it as vector. It can be also known as a row vector, and we are multiplying it with a column vector 4, 5, 6. So this matrix, what is its order? It has 1 row and 3 columns. What is this matrix order? It has 3 rows and 1 column. m cross n, m cross p. So what will be the resultant matrix? Resultant matrix will have order 1 cross 1. So how are we going to get the element here? 1 cross 4 plus 2 into 5 plus 3 into 6. That's 32. Now let's see another example. We have a column vector 4 5 6 multiplied by 1 2 3. This has order 3 cross 1, and what is its order? 1 cross 3. So we will get here resultant matrix of the order 3 cross 3, means 3 rows and 3 columns. 3 cross 3. How are we going to get that? For the first element, we will multiply the first row with the first column of this. So what is the first column here? 4 cross 1. How do we get here second element? Multiply first row with the second column. That's 4 cross t. How will we get here third element? Multiply first row with the last column. That's 4 cross 3. For this, 5 cross 1, 5 cross 2, 5 cross 3, 6 cross 1, 6 cross 2, 6 cross 3. So the matrix will be 4, 8, 12, 5, 10, 15, 6, 12, 18. Yesterday we also discussed about the identity matrix. So identity matrix is a kind of diagonal matrix. What was diagonal matrix? Is a matrix in which all the diagonal elements are non-zero, and leaving this diagonal all elements are 0. So these 3 elements will be 0, and these are non-zero elements in a diagonal matrix. So if these ABC diagonal elements are equal to 1, then it is known as a unit matrix. So this is a unit matrix, or this is also a unit matrix. So now what is the specialty, or what is the use of this matrix? This matrix will be very useful in finding the inverse of the matrix. Since this is a unit matrix, so there are few properties associated with that. These are like a common observations. You can see when we multiply a matrix by a unit matrix, it will give the same original matrix. Vice versa is also true. We know multiplication is not commutative for matrices. AB is not equal to BA. We have already seen it. We have seen A into B was 32, but B into A was a 3 cross 3 matrix. So matrix multiplication is not commutative. So that's all for today. In the next video we will be covering transpose of a matrix, adjoint of a matrix, determinants. So thank you for watching the video. Have a nice day.